So this is your B equal to 0 state. This is B equal to 1 state, let's say. And once you understand this, you can talk about other states also. And the customary say convention is this convention is here you talk about J double prime. Here we talk about J single prime. So this would be 0, 1, 2, 3, 4, 0, 1, 2, 3, etc. So let's say what we have, we are considering 0 to 1, let's say transition. As this the fundamental transition. Similarly, you can talk about 0 to 2 also exactly in the same way. That will give you the first overtone transition. But when we have a vibrational transition from here to here, it implies there are several possibilities of the corresponding rotational transitions. That means, if I consider this, delta B maybe plus minus 1, plus minus 2, and plus minus 3, that's what we saw. Other very negligible intensity, delta J should be plus minus 1. So that is the selection rule. So if we talk about that selection rule, and let's say we are considering only this and that too only 0 to 1. So we can get 1 to 2 also or 0 to 2 also exactly in the same fashion. So once we learn this, so let's see the possible transitions. So you can delta G plus or minus 1, remember. That means you go from, so suppose we are talking about any transition from here to here. This is the actual vibrational transition. But what exactly do we mean by this type of vibrational transition? Okay, so when we talk about pure vibrational spectroscopy, we consider this is just one level, this is another level, and there is no other structure. But a molecule can be in any one of the rotational states and any one of the vibrational states. So you have the possibilities, like you get actually it should be E, J, B, but we will not consider this E at this moment because that is not changing. We are considering the same electronic state, and you remember that if you go for the corresponding transition moment integral, ultimately that mu operator will give you just mu from there. So we consider only this state. Let's say J V. Let's say this is the state what we are considering. That means a specific rotational state and a specific vibrational state. Okay. So what we will see for this, the total energy, let's say E total for this means this state is energy for the, I think I was, straight away I am going there. So E total is E rotation plus E vibration. So this is from your rotation vibration. This is your centimeter inverse unit. Remember. So if I write E JB, rotation means what is the rotational energy? Can you tell?
V bar J into J plus 1.
No, you first you consider this V bar J into J plus 1 minus B bar J square J plus 1 whole square plus V plus half omega E bar minus half whole square omega E bar XC, isn't it? But now you can see, because now we are talking about this energy difference, obviously this is a negligible quantity when we are talking about such a large energy difference. So we can, in principle, take out this term. So we don't need this term because we cannot resolve it when we are talking about this. We can resolve it only when we talk about this transition, this rotational transition. Same vibrational state, you have a transition from one rotational state to the another state. But now also you are having one rotational state to the another state, but that is coming because of the vibrational transition, and that energy gap is much larger, where you cannot resolve this particular small tiny difference. So, if you have this and you remember the selection rules, say we want to find out a general expression, let's say general expression for rotational vibrational transitions. Okay, so we'll consider a specific case, let's say like this. This is actually the fundamental transition, and you can have several possible rotational transitions for the same fundamental transition over here. So let's try to analyze this, right? Okay, so think about the possible transitions and find out the line positions first, spectral line positions. The fundamental transition means you're going from 0 to 1, V equal to 0 to V equal to 1. And in general, let's say I will get any J double prime to J single prime. And what is the corresponding, say, energy change that we have to get? Okay, that means we have a transition, say, V equal to 0 to V equal to 1, and as I told you that you can do it in and side by side you are going from J double prime to J single prime. That means your transition, you want to get delta E JV for the transition 0 J double prime to 1 J single prime. So can you very quickly find out, and the selection rule obviously 0, 1 I have already mentioned, and delta J is plus minus 1. Delta J means J prime minus J double prime should be 1 or minus 1. So first you find out the selection rule, then you write in terms of J double prime and J single prime, and then we'll talk about the plus minus 1 business. So you get an expression for the fundamental transition in terms of these two rotational quantum numbers. Actually, I will have to remove it very quickly, otherwise it is getting dried up. So you find out what is delta E JB. That means you have to find out the energy of any j prime with v equal to 1 minus energy of any j double prime v equal to 0. You substitute there in that expression. You don't have to consider the centrifugal distortion. Tell me the result.
Sir, in terms of J prime and J double prime, that means the equation.
Yes. You get it in terms of j prime and j double prime.
Okay.
Your transition is 0 j double prime state to 1 j single prime state. That's it. Yes. Then. Okay. So all of you are getting this.
Yes, sir.
So let me write. So this is your delta E for 0 j double prime to 1 j single prime. This is first write the dominating term, that is I'll write omega 0 bar plus b bar into what did you say? I'll tell omega 0 bar is omega e bar into 1 minus 2x. Instead of writing this again and again, I am writing it, but this has a special significance that we will consider later. So what did you tell here? What? No, it is customary to take the final state first, isn't it? J double prime is for the lower vibrational state, isn't it? No, told you double prime means for the lower energy state. Here you can see 0 j double prime, 1 j prime. That's what it is written. Then centimeter inverse. Actually, this is called band origin or band center. I'll tell you why that is so. Band origin or band center. Okay, so do all of you get this? Others? Anyone
Yes,
else?
sir.
So all of you, you are also getting this expression?
Yes, sir. Yes, same.
Now, you see, I will get two types of branches. Okay. So, you are getting a band because there are several possible transitions. And the band will have two specific branches. So, here, I'll talk about those two branches. So, let me first draw the energy levels. These are your v equal to 0 state. These are your v equal to 1 state. Now, again, here you have j double prime equal to 0, 1, 2, 3, etc. Here j single prime equal to 0, 1, 2, 3. So first let me see delta j plus 1. That means I can go from zero to 1, one to 2, 2 to 3, and so on. So this is the branch where delta j is plus 1. So this is the branch with delta j minus 1. Okay? This is delta j plus 1 branch. You will get similar lines here. You will get similar lines over here. So they are of different nature. In one case, you have delta j plus 1. In another case, you have delta j minus 1. Okay? And this one we call as R branch. And this one we will call P branch. You remember this nomenclature actually I told you before. So this is the R branch and this is the P branch. So one important thing first you could see that your delta j plus 1 or delta j minus 1, it doesn't tell you that plus 1 should be absorption and minus 1 should be emission. Here both are absorption. Similarly, both can be emission. Okay, so that is the basic difference between the typical convention what you see in the pure rotational spectroscopy and rotation vibration spectroscopy. Do you understand what I mean? Yes or no?
Yes, sir.
So here you can see that these are all absorption lines, but it is delta j plus 1, it is delta j minus 1. These R branch lines, P branch lines. So what type of spectrum will you see out of it? So if I want to see the spectrum, say you will get one line here, you will get one line here, you will get one line here, and here you have nothing, and you will get one line here, you will get one line here, you will get one line here, and so on. So this would be your R branch. This would be your band center. You can see why this is called band origin or band center, because one side you have R branch, another side you have the P branch. That's why this is called band center or band origin, but there is no line, that is only the position. You won't see any spectral line over there. So can you very quickly find out the exact locations of these R branch lines and P branch lines? First you find out in terms of, say, J prime and J double prime, and then in one case you put J prime minus J double prime equal to plus 1. In another case you put that to minus 1. And again the customary is that for P branch lines you write in terms of J, say, single prime, and for R branch line you write it in terms of J double prime. So tell me, what do you get? Do it very quickly. So I want to get the position, these line positions. I will redraw it. What? Tell me. No, I still didn't get. So you are talking about 0 j double prime to 1 j single prime. To find out what is delta E for that transition.
Sir, for P branch, I got omega 0 bar minus 2b bar into j prime plus 1. And for R branch, omega 0 bar plus 2b bar into j double prime plus 1.
Okay. So if I write in the wave number unit, so you get mu bar R as omega 0 bar plus 2b bar what?
J double prime plus 1.
And wave number of P branch omega 0 bar then
Minus 2b bar into j prime plus 1.
so and here j double prime would be 0, 1, 2, etc. and j single prime here would be 0, 1, 2, etc. And this is in centimeter inverse, this is centimeter inverse. Okay, so now let's go back to the original one. Omega 0 bar. Here. So where will the first R line will appear? So this gap would be 2 bigger, isn't it? If you put it here, omega 0 bar plus 2 bigger.
Yes, sir.
Then again 4 bar. So they are equispaced. And similarly this side minus 2 bar, omega 0 bar minus 2 bar. Again the gap is same. Then minus 4 bar. So again all the gaps are let's say 2 bar, etc. So the first thing is if you know this line, from average you can find out omega 0 bar. And from omega 0 bar, if you get it from fundamental, if you get it from first order tone, you can immediately find out what is omega I bar and what is xc. And from omega I bar, you can find out the bond force constant, etc. Not only that, from these gaps, you can find out the rotational constant. And from rotational constant, you can find out the bond length. Okay. Now, so we know how to get various quantities from, and here you can see a principal difference is that for the molecule where you don't have the permanent dipole moment, still you can get the rotational constant if a specific mode is IR active. Okay, because vibration doesn't require the presence of dipole moment in any given system. That is not the Gauss selection rule. So even if you don't have the permanent dipole moment present in your system, you can always talk about measuring the bond length via rotation vibration spectroscopy. Now, actually, if you see the spectrum, rotational vibrational spectrum, then you'll find that all the levels, all the spectral lines are equispaced. They have marked differences and specific patterns. When you see that 2B bar gap, that is equidistant, so all the lines are separated by 2B bar with its neighbors. That is not true. So what is the basic stuff? So it is common sense. Now what we consider as if the rotation and vibration, they are two completely independent degrees of freedom. Okay. And that's what we do almost everywhere. So you go for standard statistical mechanics in the classical sense, or equipartition theorem, etc. There we consider as if one degree of freedom has nothing to do with the other degree of freedom. But that's not true. You know that whenever a molecule rotates and vibrates simultaneously, obviously one degree of freedom will just affect the another degree of freedom. So the simplest way how the spectroscopists analyze this, that the rotation and vibration, they are not decoupled. Like the rotational behavior of a vehicle to zero state and the rotational behavior of the vehicle to one state, they may not be same. Actually, they should not be same. So the simplest one, what they could come up with, is that you consider two different rotational constants, because the rotation energy levels or spectral lines, everything is governed by the rotational constant. So if you think about this, and quantum, rotational quantum numbers are basically dummy. Okay. So in this case, if I call two B0 bar and B1 bar, let's say these are the two rotational constants. This is for the ground vibrational state. This is for the first excited vibrational state. Similarly, you can go for B2 bar, etc. But what we are doing, the fundamental transition, now we will consider two different rotational constants. So now, considering the rotation vibration interaction, you find out the expression for both R branch and P branch, but with different rotational constants. For V equal to zero state, you take V0 bar, or the other one, you take V1 bar. And tell me what is the result. What is the line position for R branch and P branch? What you have to do, you have to find out the delta E, again the same way, but now you take two different rotational constants. Like first you took B bar is the rotational constant for both, but now you write down energy expression separately for V equal to zero state, corresponding rotational part you take B0 bar, and for V equal to one state you take B1 bar, and then find out what are the expressions. Before you go to put the rotational selection rule, first you tell what is the general expression you are getting.
Sir, it will be B1 bar J prime into J prime plus 1 minus B0 bar J double prime into J double prime plus 1 plus omega 0.
Wait. Maybe you are having something with you and you are just simply dictating. You wait others to follow. Okay. So we want to get, we have a transition again 0 J double prime to 1 J single prime. And what is delta E for this transition JV? So this is something what we have to find out for this transition. Anyone else? Can you tell? Anyone else? No, first you have omega 0 bar, then V1 bar, then J single prime plus 1 minus V0 bar J double prime centimeter inverse. Now you find out these two, mu R and mu P. In this case, you have delta J plus 1, you have delta J minus 1. That means J prime minus J double prime is plus 1 here, minus 1 here. And once again, you write the R branch lines in terms of J double prime and P branch lines in terms of J single prime.
Sir, for R branch, it will be omega 0 bar plus B J prime into J prime minus 1 minus, omega 0 bar plus B1 J prime into J prime minus 1 minus B0 bar into J prime plus 1.
No, I am asking you to write R branch lines in terms of J double prime and P branch lines in terms of J single prime. Okay. You can write J
Okay,
single prime in terms of J double prime and vice versa, isn't it?
so I got for R branch omega 0 bar plus B1 J double prime into J double prime plus 1 minus B0 bar into 1 plus J double prime into J double prime plus 2.
No, you try to write it in the form of a quadratic expression. Okay, like omega 0 bar plus something into J double prime plus 1 and something into J double prime plus 1 whole square.
Okay, sir.
Rearrange that. Mm-hmm. No, no, I told you write as J prime. You are talking about P branch, isn't it? So you write in terms of something into J prime plus 1, let's say plus something into J prime plus 1 whole square.
Hello, sir.
Yes.
Sir, for the R branch, the expression is coming J double prime squared into B1 bar minus B0 bar plus J double prime into 3B1 bar minus B0 bar plus omega 0 plus 2B1 bar.
This for which branch?
And for R branch.
No, no, I am telling you, write in terms of R branch, you write as if you have some A plus B, then within
Sir,
bracket J double prime plus 1 plus some C, J double prime plus 1 whole square.
oh, okay, sorry, sir. I wrote in J double prime quadratic equation. Okay, sir.
In both cases, you write J single prime plus 1 and also J double prime plus 1. That is your variable.
Sir, for R branch, omega 0 bar plus B1 bar plus B0 bar into J double prime plus B1 bar minus B0 bar into J double prime square minus 2 B0 bar.
I think you are not getting what I am telling you. Maybe some mistake in the signs. Are you getting something like this?
Yes, sir, plus 1. I forgot to say the plus 1. J double prime plus 1.
Are you getting this? And J double prime can be 0, 1, 2. If you write in terms of J single prime, you cannot start from 1. That is the reason we do it. Okay. All of you are getting this? Yes or no? And what is the corresponding expression for P? It should be in terms of J single prime plus 1.
Yes, sir.
So what do you get? Plus 1, plus 1. You have to write in terms of plus 1 because so that you can write J prime equal to 0, 1, 2. Okay. No, you are taking too much of time. Tell me. Yes, tell. What happened? Hello? Hello? No, 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 no. You get as j prime plus 1 and j prime plus 1 whole square. Why are you getting constant? No, no. Check again. We check, it should be like this, mu omega 0 bar minus b1 bar plus b0 bar j single prime plus 1 plus b1 bar minus b0 bar j single prime plus 1 whole square, something like this, and j single prime can be 0, 1. Are you getting this?
Sir, I got the reverse one. That means B1 bar plus B0 bar into J prime plus 1 whole square.
No, but your
Plus,
delta j is minus 1 here, remember.
yes,
For
sir.
P branch, delta j is minus 1. That means j prime minus j double prime is minus 1. Okay. So if you want to write everything in terms of j prime, your j double prime should be written as j single prime plus 1, isn't it?
Yes, sir.
So are you getting it now?
Yes, sir. Yes, sir.
Are you getting exactly this, or this one are you getting? Do you get this?
So I'm checking.
Here minus plus, here plus minus, and j prime here.
Yes, sir. I got this one.
What about others? All of you are getting this? So Akshay, could you find out the mistake? No, are you getting this? Are you getting this one? What is there to redo it? Adding and subtracting, you have to do so many times redoing. You don't have anything other than addition and subtraction. Then, huh? What are you doing? Lots of addition. Whatever, lots of addition. Even class 2 student will not tell this. Lots of addition. So anyone else? Could you get this?
Yes, sir. Same, sir.
Are you getting it?
Yes, sir.
Okay, now you do one thing. You find out the line positions of the first 4 R lines and first 4 P lines very quickly. First 4 R lines means R you are writing in terms of J double prime. So J double prime equal to 0, 1, 2, and 3. So you are going from like 0 to 1, 1 to 2. So first 4 lines, and similarly first 4 lines for the P. Do it very quickly. Only you have to put the values of J double prime and find out the expression.
Sir, it should be 4 into b1 prime minus b0 prime, 6 into b1 prime minus b0 prime, and so on.
What?
For sir, for R branch, the position
Yes.
should be 4 into b1 prime minus b0 prime, then
No.
6
You tell
into
me past 4 lines. What is R0, R1, R2, R3? What are those lines? New bar for R0 line, R1 line, R2 line, R3 line. R0 line means 0 to 1 line. R1 line means 1 to 2 line, and so on. Tell me. What is R0 line?
sir, that means in terms of rotational constant.
Yes, rotational constant, obviously omega 0 bar will be there.
Okay. Sir, then it will be omega, first line should appear at omega 0 bar plus 4 into b1 prime minus b0 prime. Then omega 0 bar plus 6 into b1 prime minus b0 prime, just like that.
No. There is some mistake. You check omega 0 bar.
Sir, will the first line be at omega 0 bar plus 2 b1 bar and the
Yes.
second line at
Yes,
omega 0
yes.
bar
The
plus
first
2
line would
into
be- First line would be omega 0
Hmm.
bar plus 2
2 b1 bar?
B1 bar or B0 bar?
Sir, it's
B1
coming
bar.
b1 bar. For
Yes.
R branch, it's b1 bar.
Yes, sir. B1 bar.
And then the second one?
Omega 0 bar plus 2 into 3 b1 bar minus b0 bar.
Yeah, that means 6 B1 bar minus 2
Yes,
B0
yes,
bar.
yes, sir.
Then third one?
Omega 0 bar plus 12 b1 bar minus 6 b0 bar.
Okay. Fourth one?
Omega 0 bar plus 20 b1 bar minus 12 b0 bar.
Okay. What about P branch lines?
Sir, that's I'm doing right now.
I have done the P branch lines. So,
Okay, tell.
So first one is omega 0 bar only.
No, that is wrong. How can that be? If you have change in the rotational state, there must be rotational constant.
Yes. Omega 0 bar minus 2b0 bar.
Yeah, that makes sense.
Yes.
Okay.
Yeah. Then the second one is omega 0 bar plus 2b1 bar minus 6b0 bar.
Okay.
Third one is omega 0 bar plus 6b1 bar minus 12b0 bar. And fourth one is omega 0 bar plus 21b1 bar minus
21. 20 or 21?
It's a 1 minute then. I need to.
What?
21 sir, I got. I need to change.
And Tanushree, what 20 for the last line you told? R4?
Yes, sir. 20 b1 bar minus 12 b0 bar.
So they should be symmetric. So why are you getting 20? One is 20 and another is 21. Check, either of you must be wrong. (16 plus 4 is 21). Yes. So if it is 20, someone is getting 21.
Yes, sir. 20.
Yes, sir, 20.
But if you tell now, when you are, I don't know, you are doing your PhD or masters, that 16 plus 4 is equal to 21, then obviously I should stop teaching.
No, sir. Means I have done this. Means
Really very serious. No. There should not be any excuse. Whatever you do, if you say 16 plus 4 equal to 21, there is absolutely no excuse. Okay. Okay, now to know what happens as J increases for R branch lines and P branch lines. So first we have to know the relative magnitude of V0 bar and V1 bar. Now one important thing is, in general, whenever you have the vibrational excitation, the bond length increases. I'll talk about other counter examples later in appropriate time. But the general situation is increase in bond length when you go from 0 to 1. So what will happen if the bond length increases, if you go from V equal to 0 to V equal to 1, which one would be larger, V1 bar or V0 bar?
V0 bar.
V0 bar, because they're inversely proportional, isn't it? They come in the denominator. So V0 bar is greater than V1 bar. Now, from these lines, can you tell whether the gap remains same or gap is getting increased or gap is getting decreased if you go for higher and higher J values for the R branch and P branch? You know the relative values of V0 and V1 bar. So how will you do it? First of all, how will you do it? How will you find out what happens to the gap? Say R0 and R1, what is the gap? R1 and R2, what is the gap? And as you go for higher and higher J values, whether the gap is increasing or decreasing. Whether lines are getting crowded as J increases or lines are getting widely spaced as J increases. How do you do that? You tell me your common sense. How will you check? How will you check whether the gap is increasing or decreasing? How? Come on. How will you do it? Okay. The very first thing, of course, you have to find out the gaps. So what is the gap between R1 and R0? And then you find out what is the gap between R2 and R1 and what is the gap between R3 and R1. You take right minus left. Similarly, for P branch, to find out the gaps. Then you find out gaps of the gaps. So the difference of the differences, that will tell you whether gap is increasing or gap is decreasing. So I have given you the clue. So very quickly you find out the gaps. How will you do? You find out the line position, you just simply subtract. That will give you the gap. The individual gaps, find out R1 minus R0, R2 minus R1. Do it very quickly. Yes, addition, subtraction, if you take that much of time, this is too much. Do it. So could you get all the gaps? What is the gap between R1 and R0? What is the gap between R1 and R0? You have to find out just R1 minus R0. That's it. What is the gap? What is R1 minus R0? Tell me.
Six V1, 4 V1 bar minus 2 V0 bar.
Okay, the next gap. R2 minus R1. What is R2 minus R1?
Six V1 bar minus 4 V0 bar.
Okay, which one is larger? Previous one or this one? How will you do it? First of all, how will you do it? Which one is larger? Which gap is larger? How will you do this? Any one of you? How will you find out?
Again, take the difference of differences, then
Okay, that I told. You take difference of difference and check. Considering that V1 bar is less than V0 bar, difference of difference, what happens? What do you get the difference of difference?
two into V1 bar minus V0 bar.
Okay. So which is it positive or negative?
Negative.
That means if you increase the J, the gap decreases. So you can see the R branch lines basically, if you don't consider rotation vibration interaction, they were all equispaced. But now we see that R branch lines, they are getting crowded as J increases. What about P branch lines? Obviously, your common sense will tell that
So
as
it will
J
increase.
increases, they will get widely spaced. Okay, that you will have to do it now. That exercise, I'm not telling you to do now because once you understand what is to be done, so several subtraction doesn't make you mad. Okay. Now, so if the gap increases, then you will see as J increases, the gap will increase for P branch, but it would get crowded as J increases. So at one point of time, gap will decrease. At one point of time, the gap will be 0. That means one line will fall on the other line. Then what will happen? Then the gap will be negative. Negative gap means it will go in the lower wave number side. That means it will turn from that particular point where you have the same gap, and then for remaining lines, it will go to the lower wave number like P branch side, and it will form what is called a band head. So a band will form with a band head, and the band head is a clear-cut signature of rotation vibration interaction. If you don't have rotation vibration interaction, band head will not get formed. There are methods how to find out where exactly the band head would appear. So what you see, you get like this. So here you have, as J increases, the gaps will increase. Here the gaps will decrease, and then ultimately it will go in the other direction. These R branch lines with increasing gaps. So this is the point where your band head is getting formed. This is your R branch, this is P branch, but you can see now R branch lines will come towards the P branch lines. Do all of you understand? And find out all such lines up to 4 R and P branch lines. Do you understand what I meant by this? Yes or no?
Yes, sir.
Okay. So this head formation, obviously, if you don't have this crowding and getting widely spaced, and this comes only if you take two different rotational constants. If you don't take, they will be equispaced. So the rotation vibration interaction, you will get a signature in the formation of the band head in the corresponding spectrum. Okay. So I stop here, and you will have to finish this job before you leave. Like you find out all possible gaps and check that really you'll get what we consider that for R branch lines, as J increases, it would get crowded, and for P branch lines, as J increases, it would get widely spaced. And obviously, you apply your common sense, you can do it yourself and find out where it becomes zero. And